We are the Core Shell 3D printing team, sponsored by Mechanical Engineering Department. Our advisor is Dr. Jiang. Our team members are Shelton, Seth, Alex, Wyatt, and Everett. We were given a Lulzbot TAS6 3D printer and tasked to achieve a print with an impact-resistant structure. Our objective was to create a core shell structure with a shear thickening fluid as the core, while using existing filament as the shell material. We also want an adjustable shell-core ratio to achieve desired mechanical properties. For design targets, we want the resolution, print speed, print volume to be as close to the factory specs as possible. That being said, we started modeling based on a few of our concepts. We use SolidWorks as our 3D rendering software. Our final model came out to this. 3 main modifications were made. One being the custom hot end made of resin. Second being a redesigned mounting plate. And lastly, we added a core material pumping system. This is our custom block made in resin, first edition. This is our mounting plate in all the mock-up setting. Next, we went to get hardware at our local Max. Next, we were able to start assembly of our direct drive system with modified plate and our custom block. A direct drive and stepper motor are mounted to our custom mounting plate. At the end of the direct drive setup, a heating block is screwed into the heat sink. From there, our custom block is mounted to the hot end with set screws. 2 metal plates compress our custom block to keep a tight seal. Our core material tubing is fitted onto a threaded needle. The needle is placed onto a custom plate. From there, the plate is screwed into our custom block. Springs are added to adjust the needle height up and down. This is to adjust the shell-core ratio. This can all be seen here. Onto our last system, the pumping system. Modifications to the syringe were needed for proper fitment into our track system. Independent testing of the pump system was conducted. The shear thickening fluid was not able to pump through the needle. Next, we independently tested if we could get a filament structure through our direct drive system and custom block. We ran into issues with our filament getting underneath our hot end and pushing it out of the custom block. This required a redesign of our custom block. We decided to make it out of aluminum instead of resin and screw it directly into the bottom of the heat sink. We chose 70-75 aluminum and then had the shop at NDSU CNC mill it. We replaced the core material with air to produce a hollow core shell material with the new parts. We would recommend not using resin and incorporating a larger needle. Special thanks to Dr. Jiang, Brian Call, and Rob Saylor.